want to do is to take a look at the last aspect of physical development, and then we're going to move to cognitive development on Monday, where we want to look at brain development, or actually probably more accurately, look at the development of the nervous system. The nervous system represents a network of nerve cells. We refer to those nerve cells as neurons. Now, the nervous system is actually a communication system. Now, if you remember back when we were talking about the newborn, and we talked about a newborn's crying, and that crying represented a communication system in a sense for that newborn, we had defined what communication was in its very simplest of terms, and that was exchanging messages. Exactly. We're talking about the sending and receiving of messages. And messages contain, what did we say? What's a message contain? Pieces of information. Exactly. And so when we talk about the nervous system as a network or a communication system, it's basically the same thing. We're talking about the sending and receiving of information that happens between nerve cells or neurons that controls everything. You know, it controls thinking, movement, sensories, responses, our emotions, and all of that impacts how we behaviorally react to different situations or stimuli in our environment. And so we want to get a general understanding of this nervous system and how it works, but we'll focus primarily, again, on some aspects of brain development. Nervous system is made up of two parts. The central nervous system, which is made up of the brain and spinal cord, which contains roughly about 99% of all the neurons. The peripheral nervous system links the brain and spinal cord to the rest of the body and contains a variety of nerve sensory receptors. And what happens is then when we have experiences in the other parts of our bodies, what it does is it sends a message to the brain then interprets that message, and then almost instantly then sends back a responding message of which then causes us to react. Again, it's that process of sending, receiving messages that contains information. You know, something as simple as I touch something that's hot with my finger, and the receptor cells or nerve cells in my finger instantly sends a message to the brain. And the brain's interpretation is what? Huh? Well, before the move, the interpretation is what I just touched is hot. Pain. Instantly goes back to my finger, which conveys the message, take your finger off the source. You know, that's happening instantly. You know, it's not something that we're necessarily consciously or cognitively aware of what's happening, but again, it is that process of sending, receiving messages back and forth that controls virtually, everything. Now, what we want to do is to kind of begin to understand primarily what's happening in the central nervous system, particularly the brain. We are born approximately with about 100 billion nerve cells or brain cells or neurons. And what we want to do, but the problem is, or not the problem is, but the brain, even though we're born with 100 billion neurons, the brain is still immature. All the necessary connections, or what we often refer to as the wiring of the brain, is not complete yet. It happens primarily during the early years. And so what we want to do is to begin to understand, how and the process of how these connections take place. So what we want to do is to take a look at the different parts of a neuron or a nerve cell. Neuron, here in the center, nerve cell. We're going to look at primarily three parts of that neuron that are significant to us. First part, coming off of, and there's only one of them, coming off of this neuron is a tubular-like structure. I think one of the easiest ways or analogies to kind of look at that is to kind of think of it like a wire. This one's kind of a flat wire. The wire on this machine is somewhat more rounded. But again, it's kind of a tubular structure. Wires kind of running in between that kind of represents the axon. Again, and that's up there, A-X-O-N. Again, and there's only one of them for each neuron. So this axon, this tubular structure, comes off of the neuron, And then at the end of this axon, it will branch off into like finger-like kinds of structures. Now, the most important thing to remember about the axon is that there's only one, and that its purpose is to carry information. Again, remember we're talking about a communication system of sending and receiving information. And so the axon, its purpose again is to carry messages, carry information. Okay, so there are tubular-like kinds of structures. Now, surrounding this, here's your neuron, here's your axon that's coming off. Now, surrounding this neuron are a number of dendrites that are coming off and branching off of every neuron. And a given neuron could have as many as 1,000 dendrites. One axon could have as many as 1,000 or more dendrites. Now this slide will illustrate that a little bit better. Here we have one neuron. Here's a different neuron. Here we have the axon coming off of this neuron. Again, there's just one of them. And then it's going to branch off in these little finger-like kinds of structures. And then what it's going to do is it will connect to these dendrites coming off of a variety of other neurons. And then they will make, it's illustrated here, but right here will begin to make a connection. And that's called a synapsis. And the synapsis represents that connection. It's actually a tiny gap between the two, but it is, for our purposes, the connection point between the axon of one neuron and the dendrites of many, potentially other neurons. And so the little finger-like tubular structures that are coming off the axon will then connect to the end of a dendrite of another neuron. Okay, now the third thing, and then we're going to talk about what creates those connections or stimulates those connections in a moment. But again, if we want to use the analogy, again, of a wire, and again, remember the axon is kind of a tubular-like kind of structure, very much kind of like a wire, that surrounding that axon is what we call a myelin sheath. And there's a process that we call myelinization. And again, I'll put this other one back because it labeled that for us. It's labeled right here, M-Y-E-L-I-N, sheath. And what it is, it's a fatty tissue that surrounds the axon, very much like the rubber coating that surrounds this wire. Now, what purpose does the rubber coating serve for this wire? Protect it, exactly. And in terms of our purposes, the myelin sheath tends to do two or three things. It clearly is a protection. It helps stabilize the axons. The other thing it does is it tends to help increase the efficiency of the sending and the receiving of messages. Makes the messages travel faster, more efficient in its sending and responsive processes. So again, it tends to serve two key functions. Insulates the nerve cells, and it helps to increase the efficiency. Literally a newborn baby, before over time the myelin sheaths begin to develop around the axons, the brain literally floats inside of a new baby's brain. And the connections that are being formed are not very stable. And it's not till the myelin sheath is developed through enough of the connections that literally will begin to stabilize the brain, which is one of the main reasons why there's a lot of emphasis and a lot of talk about shaken baby syndrome, why you never shake a newborn. And the reason for that is the fact that the brain is not real stable, real secure early on until, and again, it's always vulnerable, but particularly vulnerable early on. And so if we shake a newborn, literally what are we doing? Exactly. What you're literally doing is breaking apart those early connections because they haven't stabilized. And once the myelin sheaths are firmly developed, it will then give not only insulating the individual axons, but will give stability to the brain itself. So very, very vulnerable early on. And again, you break apart enough of those connections, it's going to create permanent damage. So again, what you need to know, test purposes, is know the three main parts of the neuron. The dendrites receive the information. The axon sends information. They connect, which we call the synapses, to the dendrites, and the dendrite then receives the information. And then the myelin sheath is that insulating, protective, covering tissue around the axon that helps speed up the efficiency of those messages. Now, probably for our purposes, what's most important, and again, we're talking about synapses. Synapses represent the connections between neurons. And like I said, newborn, is born with approximately 100 billion different, nerve cells. Partially, certain areas of the brain are already developed that happen prenatally, but there's still a lot of neurons that are waiting to be connected, and that's going to happen during the early years of this child's experiences of life. I think the best analogy that I can give is a little over a year ago, I had a house built, and I had an opportunity to go into the house at the point when they had done the wiring, but they hadn't put the sheetrock up yet. And I was just fascinated by it. I don't know how to do plumbing or electrical work or anything like that. But it was interesting to look at the house. And when you looked at this house, it was on 2 floors. It was just massive wires running everywhere. It was hard to conceive of that anyone would even know what wire was going where, and the fact that you could have 2 different switches in the same house run the same reciprocal. And you had different switches that ran the fan on the light as well as the light itself. And just in all of the different, outlets. It was just amazing to see the number of wires. And what I began to understand is that all those wires had to be connected correctly in order for the electrical system in that house to work properly. And that if you had one area that somehow didn't get connected to another area, that it might not only affect that one area of the house, but could potentially affect what worked in other areas of the house, as all of these massive wires then ran back to the original power source. And I was just fascinated like that. And very much like the newborn, we have this massive network of neurons waiting to be connected to each other in order for development to occur optimally and normally. And so the question is, what is it that stimulates, these connections? And what we've come to find out in research that's been done pretty extensively over the last, couple of decades is that what we're discovering with newborns is the key is the types of stimulation that the newborn receives. And that one of the things that we know is that naturally when we receive any kind of visual or sensory kinds of stimulations, that in essence we are taking in information. Whatever we hear, whatever we see, what's happening with you right now is you hear my voice and you see my movements, I'm sending messages to you. You then take in that message, and that message gets sent to your brain, of which it interprets that message as you begin to process that information. And then you respond to it. Either what's happening for you is interesting, and so you're focused, or you're bored to tears and you've phased out. But you will then react to your interpretation of that message that's been sent. And so what we've come to find that with a newborn, that what's happening is that every time they receive different forms of sensory stimulation, things that they see, sounds that they hear, physical touch, smells that occur, all of those stimulations create literally an electrical impulse that begins to form these connections. Child gets held and cuddled or spoken to, and instantly connections begin to take place. And it is that sensory stimulation that actually causes those connections to form. And then the more often that stimulation is provided, the more solidly those connections become over time. And so what we're finding is the key is sensory stimulation. We're also finding that literally a child can be deprived of the stimulation that they need. That we do know that children that are touched less, held less, have less opportunities for play, actually have smaller brains. And so again, we're finding the significance of that stimulation, and all of those different sensory domains are critical to that optimal, that normal development of the brain. That's important not only for development at this point, but it's laying the foundation for learning that's going to take place, later on. And so again, that focus is that stimulation. If you look at this slide, again, you don't need to write down the numbers. And again, what you see here, very difficult to see, represents a mass of connections that are taking place. And this is representing the number of synapses that take place at 3 different periods in an individual's life. At birth, at 1 year of age, and at age 20. Now, don't need to memorize the numbers, but what is your interpretation of those numbers? What's happening? At birth, there are how many synapses? And again, we're talking about connections between nerve cells or neurons. 50 trillion. At 1 year of age, there are 1,000 trillion. So what's happened? Which direction? Huge growth spurt. Exactly. Now, what happens by age 20? Some of them die off. Now we're looking at roughly about 500 trillion. What's our explanation, do you think? We see a massive increase during the first year of life, and then by the time we become age 20, there's actually half of the synapses that we had at age 1. All right, one of the things that we know is that if synapses are not reinforced, and again, it's that, as the slide illustrates, it's that classic use it or lose it. Is that if they're not reinforced, the synapses are relatively vulnerable, very weak initially. If they're reinforced, they will become stabilized, or what we often refer to as hardwire. If we don't continue to receive that stimulation consistently, that repeated stimulation, then those connections will disappear. Now, we may look at that and say, is that a bad thing? Not necessarily. One of the things, and I'm learning more about this all the time. Anybody in here ever do any type of gardening? Nobody. We have no gardeners in this, a little bit. Anybody know, again, whether you've done any gardening or not, you probably still understand the concept. I remember my dad told me one time, and he kind of helped me a lot with gardening, and I have a place where I built my house, and we did a lot of planting of trees and bushes and stuff. And I had trees, and he was telling me, now you need to cut off the lower limbs of these trees. Now, I didn't like to cut off anything. Everything I have that's alive tends to die. I don't know what it is. Plants in the house die. We have lots of artificial plants. Nothing happens to them much. But he kept, and I kept thinking, that doesn't make any sense to me. Why would I want to cut off living branches? Aren't I just inviting this tree to die? Now, anyone know why I was encouraged to cut off the lower branches?
So the upper branches have more the energy source goes up to the stronger branches.
Excellent. So more of the energy life sources go up to the upper branches, of which they will then develop more fully. And that's very much like what's happening with the development of the brain. In the sense that, is that when those weaker synapses, the ones that are not used that much, when those kind of disappear or die off, then it allows more efficiency use of those ones that we are continually using. And so it literally is a pruning process. And so it's not necessarily a bad thing, but it's a very healthy thing. But we begin to lose those connections that are weak and aren't continued to be reinforced, in our lives, with that. So, again, sensory stimulation, and again, that part you do want to remember for the exam because it's really important that and this will make sense when we begin to look at stage 1 of cognitive development, because we'll see that concept reinforced again. But it is providing those experiences that stimulate the senses that are going to form, and then reinforcing that over time that's going to create those early connections. Now, one of the things that we know is that the brain and the human body is very resilient. But we also have learned over the last couple of decades that there are what we refer to as windows of opportunity in terms of the early formation of these early connections. There was a documentary that came out on brain development, a primetime show that was done a number of years ago, and they illustrated the story of a woman who was initially diagnosed as being mentally retarded. And then what they found out when she was actually a young adult is that she really wasn't mentally retarded at all, But actually the problem was that she had been misdiagnosed and she couldn't hear. And that when she had been fitted with a hearing aid, she could hear normally, and that she had the capability of not only hearing, but learning. But what they also discovered from her experience is that because early connections that needed to take place when she was a young child that connects hearing with language development wasn't formed. And that opportunity for her to develop normal speech was lost, and it was lost forever. She was able to learn, she was able to communicate, but she couldn't develop normal speech because those early connections weren't formed. And what we're realizing is that there are windows of opportunity, that there are certain connections that have to take place, there are certain times of stimulation that need to take place at certain times in an individual's life because it will impact later experiences and later aspects of development. And so that when we're talking about caring for, nurturing a young child, it's more than just the necessities of life. It is providing that adequate sensory stimulation that's going to form those early connections that's going to lay the critical foundation for later learning. And we know that when a child doesn't receive adequate stimulation, here are, and again, pictures of a PET scan looking at, and again, the colors, the dark colors represent intense brain activity or synapses in different areas of the brain, showing the experience of a healthy child compared to that of a neglected child. Again, just generally, what are some of the things that you just notice? And we're not going to get into detail about what areas of the brain control what aspects of development and control what areas of our senses and behavior. But what do we see in general? And we know that the frontal part of the brain has a lot to do with higher order cognitive processing. So what do we see as we compare healthy child, neglected child? Anything just jump out at you? A lot more spaces, and there are actually areas where there is virtually no activity. And just in general, what would that seem to indicate to us? That there's some areas that have not developed, and we know that that's going to have some impact on our development and our experiences and our responsiveness, to life. We know that healthy stimulation, again, creates the foundation for learning. We also know that, that high stress, traumatic experiences literally will cause or inhibit our ability to learn, will inhibit certain connections, in the brain. And I think, again, it just reinforces the criticalness. And again, you see, some areas, again, extensive development, extensive brain activity, and then areas literally nothing that is occurring. And in some children, you see intensive activity, but isolated in just certain areas. And so, again, very critical to understand, the nature of that stimulation. Now, for just a second, what I want you to do is to image or imagine that you are a parent, and you're a parent of a newborn, and you just attended a seminar on brain development. And what you've gotten out of that is the criticalness of providing sensory stimulation for your child. And so you're focused on that. And so you want to try to provide every opportunity, and you want to tap all of the different senses. What would be some opportunities, some experiences, some things that you would do with your child that would help stimulate healthy brain development, healthy connections, develop synapses in all areas? Because we know that as we tap different senses, we're going to make different connections in different areas of the brain. What are some things that we could do? What would be some experiences you would provide for your child? And think about all of the senses. Places you might take the child. Activities you might have with the child.
The grocery store, the produce department.
Okay. Grocery store, produce department. Excellent. What else?
Reading to your child.
One of the things we know is reading to your child. And again, you tap not only the hearing part of that, but the visual part of that as well. And in some cases, you have the books that have the sense to them as well, so you can tap the sense of smell as well as the opportunity for touch. Both you're physically holding the child as well as the child touching, and as the child gets a little bit older, the ability to even turn pages. What else? Again, thinking about all the different senses. What are the different kinds of experiences or opportunities we might provide a young child? Yeah, where would be a wonderful place to go? The zoo. You know, young children love the zoo, and I think part of it is the fact that it's so sensory stimulating. All the senses, particularly smell. You know, but you have the opportunity, again, not only for the different sounds, the visual kinds of experiences, but in most zoos, the opportunity for some touch. You know, in the petting zoos, the opportunity to touch and feel different animals and to tell different textures. You know, zoo can be a really powerful one in terms of stimulation. What else? Other experiences that might stimulate. Talking, singing, using different tones of voice, the playing of music, you know, in different sounds, providing different, not necessarily instruments, but just different objects for children to play with. Again, will stimulate touch, sound, sight, and in some cases even smell. One of the places I found that my son particularly was stimulated in, which I never really thought about that much, and again, when Matthew was growing up and was really young, you know, I used to carry him in a backpack, you know, and we would go different places, and I'd put him in the backpack, and then I would walk, and one of his favorite places, come to find out, was the mall. Now, I don't know that I ever thought about going to the mall for sensory stimulation, but I remember we were walking down the mall one day, and then I could see his reflection in the windows of the stores. You know, and it was fascinating to watch his head. He was just moving all the time. What was happening? Particularly during the holidays. Sights and sounds were, you know, particularly at Christmas time, sights and sounds everywhere, and smells, you know, from the bakeries and stuff. And he was fascinated by all the, and again, in the mall, you've got constant movement, activity going on all the time. And he was just fascinated by all of that. You know, and it was one of his favorite, you know, places to go. Again, because there was so much stimulation, you know, that was happening in so many different areas. You know, so again, what we're looking at is to make sure that we're providing, you know, positive sensory kinds of stimulations so that we can form, again, those early connections. And as I've said, it's going to serve the foundation not only for what's occurring and what learning is taking place now, but it's going to set the stage for the learning that's going to take place, you know, later on, you know, down the road. So again, key things to remember in terms of this initial development. Parts of the neuron. What's the dendrites do? Receives information. The axon carries it or sends the information. Myelin sheath, protective covering or coating around the axon. The connection points referred to as synapses. Exactly. And what's the key to creating those synapses? Stimulation, even more specifically, sensory stimulation. That's what we're wanting to do. Okay, I want to take a little side note with brain development. And again, there's not a lot on this part that I want you necessarily to remember. It may be more out of maybe my personal interest as anything else. But I do think it's significant. I had an opportunity a number of years ago when I was at a conference. I attended a session on media, more specifically TV and brain development. And I was fascinated by what this speaker had to share. And I think it had some real important kinds of messages, you know, for parents, for educators at all levels, and as a society, I think, to some extent. Now, the only thing I want you to remember is that according to the presenter, he said what the media does is target the limbic system of the brain. Limbic, limbic system. His basic theory was this, and he had research to back this up, was that the media, again, particularly focusing on TV, movies, targeted the limbic system of the brain. Now, anybody from other classes happen to know or remember the two main things that the limbic system has control over or influences? No reason why you necessarily would. Anyone? Any recollection? Long-term memory and emotions. Now, real quickly, how are long-term memories and emotions connected? Why would those two be related, do you think? Long-term memory and emotions. Any thoughts?
It's when you think of your memories, it's more of the emotions that you went through at those experiences.
Exactly. What we find is those experiences that created the strongest emotions in our lives, positive or negative, are the things that we tend to remember. So he began to relate this to TV and movies. And what he said is that actually TVs, anybody know, and again, this is just a side note, you know what TV programs are primarily designed to do? Or what the primary purpose of TV programs is? It's not what we often think they are. What do they promote? What are they really about? For you, they're probably about entertainment. But what do you think TV programs are really designed for? There you go. Say it again. Yeah. Yeah, the commercials, the advertisements. I mean, they're really about getting you to the advertisements so you'll watch the advertisements and ultimately buy things. I mean, that's really a lot of the motivation behind them. And so they use the program, or the entertainment value of the programs, again, to promote the advertisements that you hope will. And that's why companies are willing to pay millions and millions of dollars to get their advertisements around certain programs, that have wide audience appeal. Now, his position was, and I thought this was interesting, is that he talked about, and you don't need to know this for the test purposes, but he talked about what he referred to as the jolt factor. That shows have jolt factors. And that those jolt factors literally create and stimulate our emotions. And he said that TV media, and there are more than three, but he said TV uses three primary means of creating jolt factors or stimulating our emotions. What would you guess they are? And you know them. Three main things they use to create the jolt factor, to stimulate our emotions, to captivate us. Okay. What would be the three primary sources of jolts, do you think? If you think about just most of our TV programs. Comedy, excellent. Humor? Drama, but more specifically, he identified, and drama is, take it to a higher intensity. What type of drama tends to create the greatest jolt? Violence. Humor, violence, and what's the third one? More specific. She said romance, sex. Said that what really creates the jolt factors is humor, violence, and sex. Now, and the others do too. Certain level of intense drama will, horror shows will do that as well. But he said those are the three primary means. Now, what tends to happen in a given show over time? Whether we're talking about humor, violence, or references to sexuality. If we watch a show, after a while, what begins to happen in terms of the level of either violence, sex, or humor? Well, it will increase for a reason, but before it does, over time we become desensitized to the level that exists. And so he says what happens is that when we start to lose the jolt effect, we've got to change it. We've got to increase the jolt factor for us to be what? Stimulated, exactly. Because we get used to it, and then all of a sudden it no longer has that effect. And so we need to up the jolt factor. And he said there are 2 or 3 ways that programs can do that. Now, what would you guess? Any thoughts about how we increase the jolt factor? And if you look at TV programming over the years, you can see it at play. Any ideas?
I think it's changed, especially with the rise of reality shows.
Okay. One of the ways that we increase the jolt factor is to increase the level of intensity. Or we, in essence, make it more real. Just a couple of simple examples. And again, a lot of ways we do that is to make it more graphic. I keep asking my son, because I'm always amazed at this, every year we got to buy new video games. And we buy the same sports video games. And I said, why in the world are we buying another football game when you have 3 others? And what do you think his response is? He has a very logical response. Why are they boring? You're exactly right. It's boring, Dad. Played it over and over again. What about the new ones? better graphics, better technology. They are more lifelike, real. So I got to have what's real. And so what happens is the others get boring. I get used to it. It loses its intensity. So I need the new ones. More graphics, more technology. It's more real. And he'll explain to me all of what's more real about it. Yeah, and we find this likewise in our TV program. Look at, well, most of you aren't old enough to go way back. But I'll just give you a simple example. I remember, if you go back as a kid growing up, I remember watching old John Wayne war movies. So you had the landing on the beaches, Well, I contrast that with, and it was a number of years ago when it first came out, but I remember going, and I saw it at the IMAX down in Branson, Saving Private Ryan. And again, if you've seen that movie, and compare the realism of that movie to an old John Wayne war movie, and there's no comparison in terms of the graphics and the realism of those two movies. The intensity of those movies was totally different. The graphicness of it was so different, completely different kind of experience. And again, if you look at a lot of our TV, and again, as you mentioned, the whole concept of reality TV, making it more real, making it more graphic, in some cases making it more explicit in certain areas. We've seen the change. It ups the jolt factor. So we increase the intensity. What else can we do? Again, thinking of humor, thinking of sexuality, thinking of violence. And we've seen this occur over the years in terms of TV program. What else might we increase if we want to increase the jolt factor? Don't make it too hard. Well, the frequency of it. We can increase the frequency of the number of violent acts in a given program, or the amount of humor, or the amount of sexual references in a given program. So we increase the intensity, we can increase the frequency. Now the third one is the hardest one. And this is what we've seen more recently. And I don't know if you'll get this one or not. I'll give you a clue. My wife doesn't particularly enjoy movies that have violence in it and overly dramatic movies or police movies and those kinds of things. But there's a series of movies that she actually will sit and watch with me. And they were the Lethal Weapon movies. Exactly. Combine one or some combination of the other three. And so what it was that she enjoyed about the movie wasn't the violence. It was what? It was the humor. And the movie did an interesting job of weaving humor in between the violence. And so all of a sudden it began to attract a different audience when you start to combine. And now what we find, whether we're talking about TV programs, movies, or video games, we find video games now that are weaving a combination of violence, sexuality, humor, sexuality, violence and sexuality together, and sometimes all three. And it ups the jolt factor. And the problem is you have to keep increasing that jolt factor in order for it to have the stimulating effect. And his basic premise is that what happens is that a lot of the TV programs, which they do in the high stimulation, taps our emotions. And our emotions will have a direct effect on what? In terms of our life in general. Affects our long-term memory, but it also affects our behavioral reactions to things. We emotionally are moved by something and then we react behaviorally to it. Now, one of the most important things he said was that one of the things that happens that the media is not particularly good at, and then what happens in terms of this whole jolt factor kind of theory, is that it all bypasses a very important part of the brain. And that is what? If it's targeting the limbic system, our emotions and our long-term memories, any idea about what gets bypassed? Short-term memory to some extent, but even more importantly than the short-term memory, the thought processing of the brain. So what happens is we watch TV programs, we're emotionally impacted by that, we remember a lot of that, but what often doesn't happen, which is why it's so important with young children that we be somewhat involved in what they're watching. What do we need to help them be able to do that the TV program in and of itself often doesn't do? And that is to think about what's being observed, to mentally, intellectually process that information, because that gets bypassed. And that's why, if you look at the experts, who talk about the impact of TV and media and movies, they talk so much about the importance, again, of parents and family and educators being involved in helping, particularly young children, make the mental connections with the emotional connections that are taking place, because that part will get bypassed. Young children have a lot of difficulty really being able to separate reality from what? Fiction or fantasy. And how we help them understand what's real and what's not real versus what they're simply emotionally may be experiencing. And so we have to help them make those connections. And if we do, and again, there's nothing wrong with the media, but it's a matter of understanding the potential that the media can have, again, on the development of the brain and in our experiences in life, and how we can make sure that, particularly for young children, until we get to the point where we can do that on our own. And I'm not even sure necessarily that adults always do a good job of making those connections. How do we help them make the mental connections, again, with the emotional connections that they may be having? Because one of the things we do know, going back to one of our theories, and again, if you remember one of our theories early on, social learning theory tells us what? Or suggests what about learning? Just in general. What we do is we remember by observing. In other words, we observe something, we remember it. Part of why we remember it is because of the emotional appeal that it may have had to us. And then what we have remembered, we're likely then to repeat in some kind of a situation or setting. And then sometimes we need, again, that cognitive processing to make sure how we're impacted by what we see and what we remember doesn't have negative consequences in our lives, but that we can make sure that they have positive consequences, and that we don't reinforce that which we don't want reinforced. We do reinforce that which we do. Because again, I don't want to assume that all that's always negative. Likewise, it can be positive programs that are also stimulating, again, emotional reactions, long-term memory that we would want to reinforce. So again, brain development early on, very important. Reinforces the notion that what happens with a child during the early years is critical for later development. And that we want to make sure that we're, again, optimizing that development, nurturing normal, typical kind of growth, and that particularly the kinds of experiences we provide are laying the foundations of the early connections within the brain that are going to impact, again, later learning in a child's life. In our next session, what we'll begin to do is to take a look at Piaget's first stage of cognitive development. It will build on what we've just talked about today as we look at what Piaget calls sensory motor, and we'll talk about that when we gather again, and then look at how, again, those early experiences help not only shape development, begin to help shape how a young child begins to look at, see, and understand their world. And then we'll look at the different stages of that theory and that level of understanding. All right, we'll see you next time.